Hello, welcome back to Every Problem. This is Stewart Calculus 8th edition, Chapter 1, Section 1, Problem 31. It's a little bit cut off in the picture, but it does say find the domain of the function. And problem 31, we have f of x equals x plus 4 divided by x squared minus 9. Okay, so the domain, which I'll write here, domain, that basically is asking you what x values and what x values, that means what x values can you plug into the function and get some answer. So what we do know is that with the function x plus 4 divided by x squared minus 9, anytime we have some denominator in a function, the denominator can't equal 0 because that'll make your answer undefined. Even 0 over 0 is still undefined. So that's a common misconception where if you have 0 over 0, people will sometimes think that that's just 0, but that's actually, that's not true. So we need to first find what the domain isn't in order to say what it is. So if we look at the bottom here, x squared minus 9, that is a difference of squares. So that's x minus 3 and x plus 3. So just very briefly, a difference of squares is when you look at a difference here, the subtraction sign, and on either side of the subtraction sign, you have two numbers that you can take the square root of. So there are a lot of videos on the internet about difference of squares. So if you have any confusion with that, maybe take a look at one of those as well. But anyways, when you factor it out, we will end up getting x plus 4 as usual, right, on the numerator. And on the denominator, we will have x minus 3 and x plus 3. And so we know we can never have 0 in the denominator. So what would make the denominator 0? Well, if any of these two terms here, underlined in yellow, if any of those equal 0, then 0 times anything else will also be 0. So x minus 3, well, if x was 3, that would make it equal 0. And x plus 3, well, if x was negative 3, that would also make it 0. So we know from that x cannot equal negative 3 or 3. Good, okay, so that means the question is asking, what is the domain? And what we'll do is we'll use a little bit of notation for that. So we'll have open bracket, negative infinity. The reason for the open bracket is because you can't close off infinity in any direction. So anytime you have an infinity, it will always have an open parenthesis at the end of it. And that goes from negative infinity all the way up to, but not including, negative 3. And that's why we will put another open bracket on that. Then there will be this big U term that you see. That means union, which just means in addition to or including, right? So we have negative infinity to negative 3, as well as from negative 3 to positive 3, again, up to but not including. And lastly, from positive 3 to positive infinity. And that does fit all of the criteria for our domain. And that's going to be our answer for problem 31.